Hello everyone, this is Rahul and I'm going to talk about producer and consumer problem. You don't ever have to learn this topic again if you watch this video carefully till the end. So what is a producer and consumer problem? It basically is what the name suggests. Producer produces a data or a variable or something and the consumer consumes it. And what is the problem here? See, when we're dealing with operating system, we have this fixed size called buffer and the producer can produce the data one at a time and the consumer consumes it one at a time. So both cannot happen simultaneously. But what if it does? It'll create a clash. And that's what's this problem about. To solve this problem, we need to use semaphores. And what is a semaphore? Semaphore is an integer variable which can be accessed only through two standard equations, which is weight and signal. And what weight does is it decrements the value of semaphore by 1. And what signal does, it does the opposite. It just increments the value by 1. Here we have a buffer of 5 slots. It could be n, but for now we'll take it as 5. And we'll use 3 semaphores, which is mutex, empty, and full. And what is mutex? Mutex is basically a semaphore to let the consumer know that the producer has produced the data, and the same thing with the consumer, that it's done consuming. To let the producer know that, we use an integer variable called mutex. If you didn't understand, that's fine, you'll get the clarity later on. And what is empty? Empty semaphore indicates the empty slots of the buffer, and the full semaphore indicates the filled slots of the buffer. Now let us initialize the values. Mutex is always going to start with 1. And empty, how many slots are empty? There are 5, so we'll use 5 as the number. And full, how many slots are full? None. So we're going to use 0. Now what I've written here is a pseudocode for producer and consumer. It's basically how the working of the code in simple terms. Let's go through the code step by step. We can see here that the producer code has a loop in it, and what it does is it produces an item. The item isn't in the buffer, it just produces an item. Let's say the item is a value A. What we're doing is we're incrementing the value of empty, which means empty is now 4 because we produce an item. So there are no longer 5 empty slots. And we decremented the value of mutex and it becomes 0 because we decremented it. As it becomes 0, the consumer cannot access the buffer right now. And now we place the data in the buffer, which is A. Now we are going to increment the value of mutex. It becomes 1 so that the consumer can access the buffer. And now we increment the value of full as well. So what do we understand by that? There are 4 empty slots and there is only 1 filled slot. So that's why the value of empty is 4 and the full is 1. And the mutex is 1, which means the consumer can access the buffer now. And what does the consumer do? It decrements the value of full, which means the full is now 0. It decrements the value of mutex as well, which becomes 0, so that the producer doesn't access the buffer right now. And the consumer, what does consumers do? They consume. And now the consumer consumes A, so there are no longer filled slots. And it increments the value of mutex again. So now the producer can access the buffer. And it also increments the value of empty because there are 5 empty slots. And this thing happens over and over again. The producer produces an item, the consumer consumes an item, and there won't be any clash because we are using the mutex semaphore as a security check. While the producer produces an item, the consumer should not interfere, and while the consumer consumes an item, the producer should not interfere. So that's basically it. And now you know what's producer and consumer problem.